Okay, let's begin with question number 10. Let's move the question to the whiteboard, please. And let's start things off. Okay, let's read and see. At 1200 hours, ship P is at the point shown with position vector 50j. And ship Q is at the point with position vector 80i and 20j. The 80i, I is something like generally position vector. Okay, so you must understand that the position vector of any point is something like this. It's basically xi plus yj. How many units of along the x direction? That's why we call it xi. And how many units along the y direction? That's called the yj part. So the 80i and 20j means 80 means if I were to just signify the coordinate just to show the meaning. This is like the 80 x value, the y value is 20. Same thing there with the q. Please take note. This is the meaning of that. Okay. Now, the ship is traveling with the velocity, they say, of just blah, blah, blah. The ship Q is traveling with the velocity. See, the velocity is kind of unique here. They, what we say, resolve it to its I and J components. Okay, that's what it means. So it's in its I and J components, the velocity is like that. So to understand this kind of meaning, you just imagine something like this, like 20I plus 10J, just giving something deeper. We don't need to know this to understand that. But think of it, what speed is this? It's something like someone is pulling at the I direction or the X direction with 20 units of some, let's say like 20 units in this direction, you're moving every time in 1 second. And then in the same 1 second, 1 hour, wrong word, that they put in km per hour. So in 1 hour is the same thing, just want to move 10. So this is what it means, that speed. That means in 1 hour, what happens is the ship moves, the ship P moves from, let's say, P1 to second position in P2. What is this? P1 and P2, 20 to the right and 10 to the top. Then 20 again to the right, next hour, 10 is thing. So that's what visually it kind of like it means, a vector definition of speed. Okay, so it's a bit more interesting, isn't it? Okay, anyway, same thing with the Q there. So let's do the first part, please, which is find an expression for the position vector of P and Q at time t hours, after 12 hours. So this after 12 hours, just a trick statement because at 12 hours, so they're measuring it a relative measure from 1200 hours itself. So how do we find that after t hours? After t hours means, I see. That means you must understand it's like the position of P will be P naught. P naught is normally used to indicate the initial position vector plus t hours. So t hours time later after the speed of P. It's something like VP like that when it's in the component form. Okay, let's put the P naught. P naught is, please take note that this is I and J, X and Y. So the I component is 0. I just write it to emphasize plus 50J and then plus T bracket. The speed of the thing, velocity is just 1 for the P. So it's going to be a 20I like that in the bracket 10J. So whenever we write a vector, we put some small line there because we can't write a bold, right, in a pen. If we're typing, we use a bold there. Okay, so 50J plus 20Ti, just like normal algebra. Please treat the vector components like normal algebra, means like terms and this and that. So meaning that these two are like terms. So there we have it. 20T plus, what is the word? 50, 20 and T, yeah? I is only got one I, 20Ti, and the other two are combined. 20T with the I vector in the direction plus 10T plus 50. This is in the J direction. 10T plus 50. So this is the position vector of P. Okay, P vector like that. Okay, this is the answer. Okay, let's do for the same for the Q, please. Likewise. So the Q can be calculated like that. So I'm just going to save this part. I'm going to cut this part and paste here. Later we're going to use this again. So I'm just doing that. Okay, so let's say somewhere down here, keep it there. So let's do the Q part first, then later will be clear why I'm showing that. For the second part of the questions, you can read. See, they ask you to use it again. So sometimes what we say, the OP, we actually we're doing, can even call it OP like that. The P vector. Means what I'm trying to say is the OP vector like that is the same as the P vector here. So let's do the Q vector likewise. So it's going to be the Q0, its initial position, plus the time and then the speed of VQ after time T. Okay, so let's have a look at it, please. So Q0 is what? Aha, it's ATI. Looking at this definition, I and J here. So the I and J, how many units like components? ATI, the X part, and 20J plus T bracket. What is VQ? VQ is the second one. The ship is traveling at the velocity of negative 10I, okay, plus 30J. Negative 10I plus 30J like that. Okay, then we just simplify it likewise. So it becomes ATI plus 20J minus 10TI plus 30TJ. Then we group together the I and I. Oh, so it becomes, so I think we got the answer for the second one also. Likewise, we can just straight away write it, just algebra. So the Q looks something like this. The I part, 80 minus 40T, just treat it like a, I is like a common factor like that. But actually, it's just writing the components, similar. So that's why we can think of it like that. So 20 minus, sorry, plus 20 plus 30T with a J outside. 20 plus 30T with a J outside. Done. So this is the answer for part 1. Okay, so let's go for the third part. Use your answers, they say, in part 1. That means using just 2 answers to determine the distance of P and Q, the distance apart of P and Q at 1400 hours. So how do we figure that out? Okay, let's take a closer look, please. So I'm just going to keep that part. Let's clear the rest and begin. Aha. So the first thing we must understand is the time is counted after 1200 hours, this point here. So at 1400 hours, the T is counting in hours is 1400 minus 12 hours, which is T is 2 hours. Oh, basically, we just need to evaluate P and Q and then find the distance at T equal to 2. So P equals to 20 times 2, I like that, plus 10 times 2 plus 50 of the J. So the vector P position, the vector P will be at new coordinate 40I, and this is 70J. This is where it is. It's somewhere at 40 and 70. That's coordinate wise. So let's do the same for Q, please. So Q, the position of Q after 2 hours will be 80 minus 40 times 2 I plus 20 plus 30 times T equal to 2. 2 hours, and then J, and then Q equals to 80 minus 80 is 0. I. So 0 I we don't write. So that part, please calculate. T is 2. T equal to 2 means 60 plus 20, 80J. So it doesn't have a component of I. Okay, how to determine the distance of P and Q? So we just need to do a P minus Q to see that. Please take note, it's a vector trick. So we just take a P minus Q, and then we must do a modulus after that. So let's do the P minus Q part first. Let's not jump it up. That means it's quite straightforward to see. It's like 40I plus 70J minus the Q is just 80J. Oh, that means the P minus Q is equal to 40 of the I minus 10J. Ta-da! Okay, so modulus of P minus Q is the distance. The modulus is always used to denote the distance. So why must we take the minus? Because we're talking about distance of P and Q. So we need to find the vector that links P and Q. Either Q minus P or P minus Q, it makes no difference except in direction. That means wherever the P and Q, not this one, like either like that or like that, wherever they are the same line segment. Okay. Okay, so that means we take the modulus of that. The formula for modulus of a vector is what? We all can remember the formula for modulus of a vector will be something like x squared plus y squared. The v is equals to xi plus yj. When the vector is like that, we take a square root, don't have the I and j anymore. So similarly here, square root of the sum of squares for 40 square plus negative 10 square. Aha. So that means we put a square root of 1600 plus 100. So they say the distance apart part of this thing, so just a square root of 1700, okay, which is just 10 square root 17, because you write in third form, because the square root of 1700 can be split as root 17 multiplied by root 100. So root of 17, the one to be hidden there, times 10. So done. That's the part, second part of the question. Okay, determine in your working, they say with working, whether or not P and Q will meet. Okay, this is interesting. They want to see whether P and Q will meet. We got two ways we can go about it actually. Using either, let me take one more small screen grab here, show you two ways, please. Okay. So one of it is here. I need maybe this part. Let me just take a nice screen grab of that line. So I clear the picture and do that. Ta-da. Let's move it here. Aha. And try to explain what it means. So whether P and Q is going to meet is going to depend on two ways. One is method one. Since we already know the P minus Q is same as telling can modulus P minus Q be equal to 0? So the modulus of that being equal to 0 is only possible if and only if the just not the P minus Q. I wanted to use the one with the T, so just not the relevant one. Okay, but the idea is correct. I mean, this part to remove. Sorry, did I just move something? Ta-da! That's not the one. So that means we'll have to derive it in terms of T. Sorry, that's already calculated with T equal to 2. So we need to do from scratch. So P minus Q like that equals to, just subtract like just now we did. So I'll just straight away just subtract and put it equals to 0. That's one way. That means each component. So that means if P minus Q in this case, tolak, the I part will be, means you understand 20T, maybe I write it do. Wanted to do fast, but I think let's not skip steps. 10T plus 50J. This is the P minus the Q. So the Q we just copy. So the minus means this one become tola. Let's put in the bracket first. That one become tola also. 20 plus 30T of the J. 20 plus 30T. This one minus like that. Okay. So when we simplify this, it becomes, this is an I here, sorry. So let's just split all of it, 20Ti. It's the same technique either way, technically speaking. Okay, instead of splitting like that, we just group it inside the bracket like that. That means the 20T with the I part. When I'm looking at this with this, these two are I's. So 20T minus 80. And then minus plus 40T. This is the I component. So how about the J component? Let's do it below. Just with this. Ta-da. So 10T plus 50. 10T plus 50, the J is minus 20 minus 30T. And this will be the J. Okay, let's take a closer look, please. 20 plus 40 is 60T. 60T minus 80i. And then this side, 550 minus 20 is 30. 10 minus 20t. And then j. Ta-da! Okay, so now being that said, this one, if you want it to be 0, the modulus of it is only possible if each of the coefficients of I and j are both 0. The vector components are j both 0, because only the then only the distance is 0, 1. So that means you must put this equal to 0. 60t minus 80 is 0, comma, and the word is and somewhere at the same time. Then this is 0. So t is 80 over 60, or t equals to 4 over 3 hours. So here we do the same. 30 is 20t, so t equals to 3 over 2. So because they're at a different time, that means contradiction. There means no such thing. So cannot. It means if it's going to happen, they're going to be at the same time. Both of this must happen, become 0 at the same time. So for it to meet. So cannot. The answer is definitely cannot now. Just one more way of showing how to do it. Method 2. Then we'll be done for this question. Okay. So a bit of a nice question here with a bit of details and just going slow so that it's more understandable. So whether P and Q, method 2 is equate the coefficients. Exactly the same thing. It's like equate the coefficients for the position vectors of, because they're referencing from the same time, and position vectors of P and Q. So position vector of P and Q. That means we're equating these two, put equal, like I show this straight away. So 20t by looking at the coefficient. So we're looking at the coefficient of I, we're going to get one this thing. Of j, we're going to get another equation. So the red one now tells me that whatever coefficient, whatever in front of the I only. So 20t equals to 80 minus 40t. And then at the same time, on this side, we can simultaneously write these two components or coefficient of j to be equal, which reduces to 10t plus 50 equals to 20 plus 30t. So let's try to solve it, please. So 60t goes to 80, you'll get the same thing. 4 divided by 2 is 80 over 2 is 3 hours. This one just calculating, you get the same thing. Just showing fast. So it's 30 is 20t. When you bring in subtract like that, t is 3 over 2. Same contradiction, which is not same. If it's not same, they do not become 0 at the same thing. So cannot. So contradiction. That means what does it mean? Why do we want it to become 0? Okay, when the position vector difference is 0, then we put it equal. Like here, there's no difference is 0 means they're the same point. There's no difference between the distance or position vector. So here we put it equal means they're in the same exact coordinate. So position vector meaning that they will meet. Thank you.